So let me go ahead and get started. Hi, everyone. I'm Sam Van Oort from CloudBees Incorporated. Today, I'm going to talk a little bit about performance and pipelines. You've seen a lot of talks today from different people at different companies, especially focusing on pipelines and Jenkins, which most people agree is sort of the future for delivery. And I have to admit, I have a problem. I'm not a patient soul. I might not be the only person in the room who feels this way, but I hate staring at a build for 20 minutes, watching it finish, and waiting for the tests to complete. Am I the only one in the room who feels that way? OK. I'm glad I'm not alone then. So today I'm going to talk about a variety of different ways to make your builds and tests and deployments go faster with pipeline. Kind of cover a range of different areas. First, I'll give some background kind of on the problems with pipeline and where you should care about speed and what speed really means. Then I'll go into some of the tools that we have available to look at performance for pipelines with an eye to making it go faster. And then thirdly, I'll talk about some of the best and worst practices with pipeline. And hopefully, I think you'll find that very useful. So let me first go into a little bit of background. Let's talk about what fast really means. I think everyone agrees that fast is good as long as quality doesn't go anywhere. I mean, we are at a CI/CD conference. We're all Jenkins users. We don't want to wait forever. But it means different things to different people. So there's really three terms that you'll hear bandied around for talking about speed and performance here. There's throughput, basically how many things you can push out in a given unit of time. There's resource use, which is how much computational power, memory, network resources, or other things you need in order to accomplish a goal. And then there is latency or turnaround time, which is how quickly something goes from A to B, basically. So breaking these down. So throughput is something that I think is less of a concern for people using CI/CD. And here's why. Throughput is very easily solved by scale out. One of the most common patterns once a team grows beyond a very small Jenkins installation, like a couple of developers, is to distribute out a lot of the work to a swarm of build agents, what used to be called slaves, and let them do all the heavy lifting while the Jenkins master is just acting to orchestrate it. So that takes a lot of the load off of one system. You can take that a step further once you start to hit scalability concerns with one Jenkins master and split it out to multiple ones. Often, very large organizations will do, say, one master per division or per large development team. So it's very much a problem with a known solution. So I would argue that throughput is not a concern, not anymore. As far as resource use, I think there's one really good way to look at this, and that's cost. So throwing up here some basic figures. The cost of one basic computational unit, let's call it a AWS C4.x large instance, fairly standard. I'm using that because it's a reasonable baseline. 4 cores, just shy of 8 gigs of RAM, cost $153 a month. If you reserve your instances, that's $100. This is basically spin up on demand, ephemeral, you pay for what you use. So that's basically the most expensive model compared to dedicated data center infrastructure. You're paying for just what you use and what you use now, but you're paying a premium for that. And each one of those instances might be sufficient for dozens of engineers. Now, compare that to engineers. As you can see, there's a little bit of a difference. While your hardware is fairly cheap, I mean, it's about the cost of going to a couple of good concerts a month. Software engineers are a little bit more expensive. So I've got kind of a range here between sort of, I guess, junior engineers in some of the more low cost of living areas and very senior engineers in Silicon Valley. I'd love to be making at the top end of this range. But basically, your hardware is much less of a concern price-wise than labor. So people have said, just throw more machines at it. There's a reason. I'd argue that we shouldn't really be optimizing for resource use unless we are making a big difference. So that brings us to the third option for speed, latency. This is the king. I think I asked earlier who here hates waiting for a build. This is that exact number. This is basically the amount of time you're sitting there twiddling your thumbs, waiting for the build to pass or fail, waiting for something to deploy. This is the time when someone says, "Ugh, it's going to be 10 more minutes. I'm going to go grab a cup of coffee and come back." And maybe it gets into a conversation along the way. Context switching. Context switching is expensive. Who here has had someone come over and say hello when they're in the midst of working on something, and then 10 minutes later they come back to it and they can't remember what the heck they were working on? Can I get a show of hands? Yeah, OK, most of us. Yeah, so that's a really familiar feeling. So by optimizing for reduced latency, we're reducing context switching and reducing the amount of labor needed. We also happen to ship faster, which is something that is particularly popular with management, I think. That's a nice perk. All right, so this is what we're going to focus on is latency. So as people who work with Jenkins, let's look at what the components of latency are when you're using pipelines. All right, so there's a couple of parts. You can think of it as a multi-stage process. So the first part is someone submits a source change. You see it hit the SCM. How long does it take before Jenkins picks it up and can do something with it? The triggering delay. And I'm going to talk more about how each of these can be optimized and what influences them in a minute. So next, once it hits the Jenkins instance, you'll have a job in queued. There's some unmaster overhead for loading the pipeline script, kind of kicking off all of the needful and tracking that. And then you're basically going to be waiting for an executor to do something, whether it's a build, a deploy, a test, sending an email to someone, whatever. But if all of your executors are taken, there's going to be a lag. So the fourth part of latency is the biggest usually. That's the time you're actually doing real, meaningful work on your executor. Usually that's going to be a shell step for pipeline, a batch step, a deployment call. This is going to be something that needs an actual writable workspace to do something meaningful. And then finally, once you've done that, it doesn't really matter what you've done until someone can see that, right? So then the final part is the feedback delay. That's basically how long it takes before someone who cares about it sees the result. It doesn't really matter if you sent an email, right? Because, I mean, let's be honest. How many people get a ton of different spam emails from all over the place? Maybe some of them are build notifications. Maybe they get seen, maybe they don't. We've all gotten kind of that spam flurry, right? So it doesn't really matter that you've done something with it if someone who needs to know doesn't know yet. So let me break that down a little bit more. All right, so looking at each one of these components, I'm going to talk about some things that probably will be reviews for some people, but I would be kind of not doing my job here if I didn't at least touch on them. Triggering delay. So there's a couple factors that influence that. One of them is latency between your SCM, your Git repository, and your actual Jenkins instance. Usually that's going to be fairly small, though. We'll call it a couple hundred milliseconds to cross the Earth. So not a big component, usually. The bigger part is going to be polling or commit hooks. How long is it before Git knows that something's happened? So polling is basically the equivalent of going on a long car ride with your family as a kid and saying, "Are we there yet? Are we there yet? Are we there yet? Are we there yet? Are we there yet? How about now?" And while this process will eventually get you an answer, it's very wasteful. Basically, the speed of turnaround is directly proportional to how frequently you do it. Unfortunately, this is a terrible thing to do to your poor overworked SCM, your Git repository, GitHub, Bitbucket, Subversion, take your pick. It's also not great for your Jenkins because you have to keep a lot of open connections for polling. And finally, you don't actually get an immediate response. So the better way to do triggering is to have your Jenkins host set up with a webhook. Every time you get a fresh commit in, Git repository or SCM of choice sends a notification to Git to say, hey, we just got something new, let's build it. This also avoids things like the dreaded GitHub API rate limit exceeded message, which is everyone's friend right before a release. And this is why you want to have webhooks. So next part, the on-master overhead, very standard things. Clear off your old build records so you're not overwhelming the master and its resources. Don't give the master any executor so it can focus on orchestration and not actually doing builds, frees up CPU. And this last one probably should go without saying, but I'm throwing it in here because I've actually seen this in the wild. I've seen it completely bite people in the wild. If you're throwing gigs of data into your log files, guys, that's going from your build agents all the way back to your master. It's got to be written somewhere. It's not going to like it. I think we all kind of know that, right? You can push it on something else, put it in Elasticsearch, what have you. But if you're streaming it directly to your Jenkins logs, that's going to be a problem. All right. So next up, executor use. Very simple. We must create additional build agents. Dynamic agents, take your pick. You can use a pool of Docker slaves, Docker agents. I will do that again, probably. You can use cloud provider of choice to spin up agents on demand. But very simple problem, very simple solution. Finally, feedback. So this is the one that I think a lot of people get wrong, and it's very easy to get right. Sending notifications does not equal sending notifications to people. For every message you send, maybe 1 in 10 is going to be read by someone if you're not filtering it down to what matters. So you see in many organizations someone setting up a notification for every single Jenkins build, every single job that's run to say this giant email folder with 50,000 messages in it, hey, we ran a build. That's like your kid saying, hey, I went to the bathroom successfully. This is something we should take for granted. Notifications should be things you care about. Build failed. Build exploded. Deployment to production happened. Basically, the less messages you send, but the more meaningful you are, the lower your feedback delay is, because it means someone's going to see it. And I also recommend using IM with pipeline, be it HipChat, Slack, take your pick, rather than email. The reason for that is that those tend to be seen a little bit more immediately. People are kind of tuned into checking email periodically. If it's something critical like your deployment to production blew up, it's probably better to know about that now than later. There's a reason ChatOps is the thing these days. All right, so that's kind of getting the basics out of the way here. All right, let's talk tooling. All right, so we've got a couple of things that have been added to Jenkins in the last recent interval to help you deal with performance. The first one is pipeline stage view. This was released to the open source community back in March. It's a visualization of stages within your pipeline. Think of it as the sort of top level view. I'm lucky enough to be the maintainer right now. So if you have issues, I'm going to go hide. No, if you have issues, come up to me. I can take a look at it. But it's really good for kind of broader things to look, for example, at build, deploy, test. How long is each of these phases? We've recently added support for block scoped versions of this syntax. And that's significant because it means that when you use a stage step, as you can see up top, to kind of label a block of your pipeline, you can define a start and end. Previously, it ran from one stage to the next stage. So you can say that I want to construct a timing from here to here and only include these steps. That's actually kind of useful. It's also good for kind of performance debugging. You can put in an extra stage somewhere just to track to see, for example, how long one particular test case is running. And I've got a sort of a crude example here for you guys to look at. In this case, we're looking at different ways of echoing output. This might be surprising, this might not be surprising. So basically, the first one is sort of a crude print a message, native pipeline syntax. As you can see, it's basically free. It's very fast. If you actually do that in a shell step, though, which is a pattern that I have seen a lot more than I would like to in the wild, you'll end up taking quite a bit longer. So for example, if you're doing something that I've seen, which is taking a shell script and feeding each line to pipeline to run using a shell step, you will see maybe not the performance you'd like to see. If you run 1,000 of these, it does add up. Fortunately, you can consolidate. Bash is a wonderful, wonderful language. It allows you to do a lot with one small line. So if you combine all of those little tiny micro steps, it'll run pretty quick. You can see you basically have a third of the speed, or a third of the time required, rather. So that's the top level. Let's drill down a little bit more. I'm going to show you something that I suspect most people will not have seen because I released it just last week. I've added to the pipeline steps view the ability to see timing. I hope that's visible, but if you look at each line here, there's a time in milliseconds next to it, or seconds, depending. So every single step of your pipeline that you run creates an individual entity, a flow node, with a defined start and end point. So with this, you can drill down to the level of an individual shell statement, an individual echo command, an individual archive command, to look and see just how long you're spending every step of the way. Think of it as your profiler for Jenkins. You can also look at the block level. So for example, how long are you using an executor? That's a node block. How long are you spending within say, a wait until block? How long are you spending using a Docker container? So this is kind of your fine-grained approach. There's also the new hotness that I think everyone's heard, Blue Ocean. This is sort of where the torch is being passed. It has per step timing, and that's kind of going to be the future. And let's talk numbers. Okay, so I showed you sort of the tools there. This is the result. So when you run a step, there's a very small overhead associated with each step. As you can see, the echo step, which is sort of the trivial case, pretty fast, less than a millisecond. That number is not 0. The reason it's not 0 is because every single step that you run in a pipeline is persisted. So when I say I want to run one shell command, I have a record that that shell command was run that's permanent until you delete the build record. And when I run an echo, I have that same result. When I throw an error, I have that same result. There's a very small overhead to that tracking, but it is present. Obtaining an executor slot or a workspace within an executor, very cheap, 20 milliseconds. Realistically, these are, say, 10 to 30 milliseconds. This is running sort of a fairly baseline server. Running a shell step does have a significant overhead. It's about a quarter of a second. I kind of harped on that a little bit earlier, and the reason for that is that pipeline is designed to survive everything short of a nuclear war. It's like it's durable. I was going to compare it to something else, I probably shouldn't. This is significant for shell steps because your shell step will survive beyond the restart of your Jenkins master. So it's got provisioning so that it's starting a shell step that's running in the background and pulling logs from that. And it's kind of configuring, think of it as like a background task to run continuously, and it's just checking back to it from the master. There is no overhead for that, but it's also nice because it means that your deployment shell script isn't going to be completely lost when your job dies. Who here has had a long-running job that was doing something with shell commands or Maven and had your Jenkins master just die in the middle of it and had to start all over again? Can I see a show of hands? Yeah, okay, so some people, not everyone, thankfully, but as someone who's been there, it's not fun. So you do pay a little bit for that privilege, but it's a fairly small amount. And as you can see, if you look at a build itself, a very fast 1-minute build that is kind of the ideal world that we'd all like to have happen, and may not always achieve, this time dwarfs all of the other overheads. Worth noting, that's a logarithmic scale. So the step between obtaining a workspace and running a shell step is an order of magnitude difference. So that's significant. OK. So let's talk about some of the things that come out of this. What should I do? What shouldn't I do? All right. So I'm going to talk about worst practices first. This is a hardcore anti-pattern that I would describe as breaking the world. This is something that I've actually seen in the wild in a couple of cases. And it's something that's very easy to do, and it will completely break a production master if you do it wrong. So this is your warning label. Think of it as the siren on the top of a fire engine. The first way to do this is basically to run an input step in the middle of a node block. This is part of a class of problems that boil down to basically waiting forever. Because computers are dumb. They're not going to stop running unless you tell them to. So what this will do is it's going to lock up one of your build agents because it needs a workspace. That's what the node block does there. And it's just going to sit and wait, because that input step is not going to finish until someone comes back and says, OK, we're done. Let's approve this to go forward. Let's abort it. So this is a really easy way to end up with a bunch of your executors chewed up and not any idea why. Don't do that. Put your input step after your node use. That's something that runs in master only, occupies almost no resources. It's basically free. Question?
Why isn't that a syntax error?
That is in some cases, actually. The pipeline model definition is, the Jenkins file version 2 is actually doing validation for this. There are a few valid cases where you would want to do this. One of those is, for example, if you're testing with embedded hardware, and there might be a physical device that's tied to this particular build step. So like, for example, a smartwatch, maybe. And you want to wait until the physical device is attached or something's been done with it. But in all cases but that, it should be considered a really bad error. Fair enough? All right, cool. All right, so the next one is, I call it the waiting for Godot pattern. The reason for this is basically you're waiting forever. This is like turning on your garden hose and going for a month-long vacation. Except you've left your garden hose, say, in a pond that's going to drain down into your house. So what you're doing here is, I should explain, this wait until step is, it's not a commonly used step, but it is part of the baseline pipeline syntax. What it does is run something until it returns successfully. So in this case, we're running a shell script that will never return successfully. Let's say, I don't know, you're trying to connect to a host that's down. Now, this is one I will mention that I have seen in the wild on big systems, big systems. And it's a problem because remember how I mentioned that pipeline is creating a little breadcrumb step of every part of the execution? What do you think is going to happen when you do that endlessly. This will run very fast. Remember, these shell steps take a quarter of a second to run, 10 milliseconds for the node step. So you guys can do the math, right? It's going to take not very much time to accumulate thousands, tens of thousands, hundreds of thousands of steps, each one logged with its appropriate little breadcrumb. In fact, this one's particularly bad because each one of these blocks has a start and end node. So you're going to get 1, 2, 3, 4, 5 little records for every single cycle it runs. 2 for the wait until, 2 for the node, 1 for the shell. Okay, so why do you care? What's that? Yeah, okay, sure. So with this step, with these blocks, every one of these has a start, an end. Each one of those has a separate record. This lets you do analysis on it. It tracks state. So in this case, because you've got a nested block, you have four nodes for the 2 blocks, the node block and the wait until. Each cycle is going to generate a new pair. And then you've got the shell step inside of it, which generates a record. Normally, we don't care, because these are very cheap to create. But if you generate tens of thousands, hundreds of thousands of these, each one of these has to be loaded into memory when you do analysis in the pipeline, when you visualize it. When you work with it, it does keep a certain amount stored in memory because it needs to have that accessible. So it's very easy to create an abusive build like this that will require loading an absolutely obscene amount of RAM to walk through it or take a long time to visualize. I should mention, by the way, that I did an optimization specifically for stage view that's also hopefully going to make it into Blue Ocean as well, that caches the results of these. So the impact on users is not as bad as it would be if it was running it from scratch every time. But you don't want to do that in your production master. So let me show you the better way of doing this. All right, we put a start and end on it. So we're going to put a retry block here that says basically we're going to run this up to 3 times. If it never succeeds, we're going to throw an exception, throw up our hands, and say, we're done. And that's your opportunity to try to clean up the result, to roll back cleanly, and move on. So this is something I would recommend for anything that's likely to fail, network requests. You're hitting someone's API. Basically, it's just a safety measure. Another one that I would recommend is the use of a timeout. So this is a little bit subtler. This is things that can hang unbounded. I'll give you one good example, is a network request or database query. If your step under the hood is doing something like that, you will hit problems if it never completes. I'll give you 2 cases. If you're deploying or doing a network call, you need to have a timeout around it. Or you need to have a step that implicitly does a timeout. Yes, really. You will break yourself eventually. It might not be today. It might not be tomorrow. But you will see an explosion. I've seen the logs, the tickets from customers, tickets from users who have encountered this. This is also a really good one to combine with a retry. All right, so I've talked about the bad. Let's talk about the good. All right, so those are problems and ways to fix them. This is your big time saver. This is something that pipeline makes very easy to do, parallels. Parallel steps let you use however many executors you want. You can actually run parallels on a single executor too, if you'd like. It splits up the work. And there's a couple of best practices around this. So I'll give you first an example. This is kind of loosely modeled in some of the work I did for the Jenkins project itself with a Dockerized test environment for the packaging. But it's a little bit kind of generified for common use. So in this case, you run a series of tests in sequence. Let's say you take 7 or 8 minutes to run each of them, one of the Linux tests. Similar for the Windows, maybe a couple minutes for the unit tests. Very quickly, you end up with like a 30-minute test cycle. Parallelizing, you can cut that down to, say, 7 or 8 minutes. There's actually an extension beyond that I would recommend, which is canaries. The reason I recommend this is that if you parallelize like this, you can chew up a lot of executor slots. I've actually been guilty before of chewing up a lot, far more than I should running tests this way. It's helpful to put the tests that are the most critical and most likely to fail up front and batch them. The reason you still want to run parallels in this case, besides the performance, is that it's helpful to have the results of those tests, because the only thing worse than a long-running test is a short-running test that returns one failure and you don't see the rest, right? Because you go back, you're like, okay, I fixed the bug, now we kick it again. Well, there's 3 more bugs after that. So both of these patterns accomplish that goal, but still give you a faster feedback cycle and reduced resource use. And there's one other little trick that I'm going to show you in the next slide that ties in with this. Yeah. Bottom left or bottom right is kind of it's a toss-up between how much resources you have available. So you're basically trading extra CPU power, extra build agents for more data coming back. So for the one in the bottom left, basically you're going to have, if you have it set so it doesn't fail until all of the branches have completed, you'll get back the results from all of those. For analysis, the one in the bottom right, you'll get back whichever parallel block you're currently running. But it'll take a little bit longer. So you're doing a couple of trade-offs there. There's one practice I'm going to recommend in particular in conjunction with this. And this is something that I've seen internally at CloudBees, but I think I have not seen in the wild as much as would be helpful. And this is a really kind of a clever trick. So Parallel has an option called fail fast. I'm not sure if everyone knows about this, but what it does is say that if any of the branches in a parallel block fail, we're going to bomb out, abort all of the other branches, and throw back our exception, which is really helpful if you want fast feedback. But in this case, it also means you swallow all of the other errors because those builds don't complete. The default, I believe, is to have fail fast off, so you'll complete all branches and then return the failure. In this case, what you can do, though, is go ahead and wrap each one of those branches in a callback, basically. So you take a closure. This is Groovy. Pipelines full Groovy syntax, so you get that perk. And you say, OK, this failed. We're going to send back an exception and then throw up the exception. And that way, you can still get the fast feedback. But because you've got fail fast set to false, you can still get back the full test results. You just get feedback a lot quicker. This also means you can get multiple notifications if different tests bomb out. So this is something I would recommend everyone who's got a pipeline with parallels put this in here. This one's set up as sort of a basic HipChat notification. Make it email, make it Slack. This is a way to get your users the information they need quicker and to use less resources than trying to finish everything, basically. It avoids having to run multiple cycles. Yeah.
So the way to control that behavior is the first entry in the app that has the parallel set that parameter?
Yeah, hold on one second. Let me pull this back up here. Yeah, so fail fast. So it's treated, the parameters to a parallel are just a map. So this is kind of a magic parameter. It should be in the documentation, but you're just passing in that variable mapping. Yeah, so you can pass true or false, basically. You don't actually, in this case, don't actually need to explicitly set it because fail fast is, I believe, false by default. I'm just putting in there for kind of thoroughness so people realize what you're doing. All right, so one other kind of a smaller optimization, consolidation. We're going to put everything together here. Node blocks. So one of the kind of anti-patterns you can hit if you have complex pipelines, and you guys have seen this with freestyle jobs too, is that you acquire a lease on a node, you go do something with it, you return it, and then you go on to the next part of your build chain, and something else grabs that. Maybe it's someone's long-running set of Selenium tests that need 3 hours to run. and you don't get that build agent back. So basically, it's very possible for someone to swoop in and steal your build agent out from under you, and then that means your pipeline takes a lot longer to run. So best practice, I would say, is to consolidate use of node blocks. One thing you can do, too, is putting a lot of the on-master, kind of the groovy evaluation up front before you acquire a lease in a node block, wherever possible. That means that your period that you're using it is shorter, and you are using it more effectively. Also, batching together shell steps I mentioned, and one third little bit, and I'm just about to wrap up here. So parsing and complex processing. Pipeline does kind of a complex transformation to convert Groovy to Groovy CPS code, continuation passing style. That converts to a format where the complete state at any given time is carried from one function to the next. But that's a kind of expensive transformation. So if you want a little bit more speed with processing, you could annotate something at non-CPS. That marks it as not transformed, not serializable, makes it faster. It's really useful for like a callback that you're doing something like XML processing. There's a catch to that, of course. You can't run any steps within that because those require persistence. And the next step is just to create a helper script. I'd recommend that. If you're doing anything that's going to take more than a second, do that. Just create yourself a little shell script, a little Python, Groovy, take your pick, Ruby, do that. So this is kind of this sort of best practices, some little tricks here. And just to kind of give you sort of an overview, we've gone through why I think you should focus on latency over resource use or throughput, because it optimizes for what matters, fast results, reduced technical labor, and means you don't have to care about CPU use, which is much cheaper. It's also easier to measure, too, and easier to use as a metric. A couple of tools that you can use, Stage View, which will eventually be converted over to Blue Ocean use. The pipeline steps view now has timing information. And you will actually eventually be able to dig into Stage View for per-step timing, too. I've got a PR out right now. I just need to basically cut a release on that. I'm going to throw a few other things in there, though. Best practices, use your parallels. Use them often. Fail fast, false, and fire notification is really helpful. And call your notifications early and often. Echo statements are basically free. Use those. Those will save so much grief, having that extra information for debugging. Also, the big anti-pattern, don't block, don't run things without a bound, don't kill your Jenkins master. And that's it. I hope everyone's had a good time at Jenkins World, and thank you for your time.